This video is going to cover section 1.2 in Math 115, observational studies versus designed experiments. So start by reading these two, example 1 and example 2. Pause the video, read through them, and then we'll think. All right, so when you're ready, what are some things that are the same in these two study experiment things? So they're both looking at cell phones versus brain tumors. They both, wow, that was bad spelling, brain tumor. They both come out with the same results, that there's really no link to be found. Some differences. Example 2 uses rats, while example 1 uses humans. In the first one, they just observe people. The second one, they control which type, if any, exposure they had. And then the first one only had 2 groups. Second one had 3 groups. And there's other things you might have found. Those are just some of the things that are the same and different. Example 1 is an observational study. They found a lot of people. They followed a lot of people, over 790,000 people, and found, 1,261 tumors. This is no significant difference. The reason they say that is because later on you'll learn there's mathematical percentages or numbers that make it significant, saying that, hey, there's probably a link. This is such a small number that they're saying they're not showing us a link. It's not that different than the other group. Example 2 is an experiment because they separated. Group 1 got analog frequency, group 2 got digital frequency, and group 3 got none. So they made sure that the radiation was different. And then everything else was kept the same. So they controlled all of those other variables and such. And they still found the same results. No statistically significant differences in the groups. So that's just kind of a quick thing. Now, we talked about variables in the last lesson. Here we're going to be more specific. So explanatory variables, those are the cause or the explanation. So in the above things, in those two examples, the explanation would have been the phone use or the radiation exposure. The response is your effect. What happens when you're exposed to that explanatory variable? So in this case, it was brain tumors. Observational study measures the responses without controlling anything. So it measures the response to the explanatory variable without controlling anything. So they're just watching. Whereas the experiment measures the response. Let's see if I can spell. Measures the response while controlling other variables. So they control as much as possible in order to be able to say it's actually a cause and effect. So with experiments, because you're controlling, you can say this is a cause. In observation, you can only say they're related. You can't say it's a cause because you don't know what else, you haven't looked at what else could be affecting it. You can say, hey, there's a relationship, but you can only say cause and effect when you have experiments. So, which is better and why? Well, obviously, if you're looking for a cause and effect thing, an experiment is going to give you that, especially if you do it over and over again. But we're talking about like brain cancer here. It's not really ethical to give people cancer. If you're pretty sure this causes cancer, you're not going to expose people to it. That's why in the experiment, they did rats. Now, besides the point, we're not talking about animal testing. Like that's a whole other ethical thing. But they used rats because they didn't want to test it on people. Versus the study, they're not making anybody get radiation from the cell phones. People are choosing to use them and then they're looking at the results. So sometimes ethically, the observational study is better, but your results are more prominent and more like fulfill, like, what's the word? They can say this is more likely a cause than not. Studies also cost less. So if you're not sure, it might be good to start with a study, spend less money, and then if you do this, you say, hey, there's really no relationship, so it's not worth going into the experiment. Versus, hey, with that study, we see a pretty good relationship, maybe then we do an experiment with the rats. Who knows? There's lots of reasons, but neither's better than the other all the time. All right, so here is another example. Read through that and then check it out. All right, so pause if you need more time. If not, this looks really good. You know, when you read through this, they're saying, hey, seniors who get flu shots are less likely to be hospitalized and even more less likely to die. That's awesome. This would be a great thing for people to use. They did a study. They watched these people. They looked at a lot of people. They looked over a long period of time, all kinds of things. But they didn't consider overall health. Like, how many of those people that died also had cancer or an autoimmune disease or something like that? They didn't look at contacts or how many people they were around. Did these people live in a home where it's only the old people and the nurses? Or do they live, like, in a house with families and lots of little kids that go to school? They didn't look at access to doctors. So the people that are getting flu shots have to go to a doctor or pharmacist to get them. So maybe they have more access and they went and saw doctors when they got sick instead of going to the hospital. There's lots of other things that could be considered that could change the outcome. So while this is promising, unless we know the answers to those things, it's not super helpful. So these are called confounding or lurking variables. Confounding is when the effect of multiple variables can't be separated. So if we don't know people's history, spelling again, separated. If we don't know people's history, we can't separate their health, their current health from the causes. If they're already sick when they get the flu, that's different. We can't separate which health impairment was the problem. This affects whether you can look at causation. You may be able to say, hey, these people were already sick, but that takes away our ability to say whether it was the flu shot or maybe some other medicine they were taking or some other sickness that made them worse. So that's just confounding. It's saying, hey, you recognize this other variable, but you can't separate it. A lurking variable is when there's an explanatory variable that you didn't originally consider. Not originally considered. So that's like the access to contacts. Maybe some people were around more people, or their access to healthcare. If this person had a ride to the doctor and could go whenever they needed to versus person B who couldn't, they're going to have less access to healthcare. So those may be things you didn't think of that in the end you're like, oh, that could have affected it. So now these are taking away your ability to say causation because you didn't think of them and you didn't control for them. If you know you have a group of 100 people that have varying access to healthcare, you might separate, okay, half of this group that has the same access looks at flu shots and doesn't, and then half of this group that has different access looks at flu shots and doesn't, and then you're taking out that lurking variable because you've accounted for it in your groups. Again, we'll get more into that when we start looking at studies, but those are just two ways that even if you have a really good study, variables can get in your way. All right, so observational studies can't claim causation because you're not accounting for those lurking variables and the confounding. So why would you do them? Well, in theory, they're more ethical, especially if you're talking about something that's bad. Like, I think smoking causes lung cancer. I'm not going to make people smoke 2 packs a day if I'm pretty sure it causes cancer. So I'm going to do a study with people that are already smoking and look at different groups of them before I make a decision. it's a cheaper way or a more ethical way to get started. Maybe I do a study and I find a connection I wasn't sure I was going to find. Then it says, hey, let me look more into this. So even if we're talking about cancer and there's all kinds of different meds, maybe I made this new medicine, and I'm going to do this study here, and this medicine doesn't work. Well, I'm not going to go spend the money on an experiment. There's a lot more details to medical studies, but there's things like that happen. So they're good starting points. Sometimes they're the only way you can start getting information. So we're going to go over 4 different types of observational studies that you could see. A cross-sectional study asks a group of people a question right now. So I'm going to say, hey, these 50 people, I'm going to ask them right now, do you smoke? Do you have cancer? Or do you use a cell phone? Do you have a brain tumor? So it's awesome. It's easy because it doesn't take a lot of time. It doesn't cost a lot of money. But on the other hand, you don't get a full picture. If you're asking people and then 10 years later they get a tumor, you don't know about that. You only know about what's happening right now. You don't necessarily know how long they've been smoking, things like that. So you don't get the full picture, but it's a good starting point. Similarly, a case control asks a bunch of people, but now you're having them think or look back about the past. So you're saying, hey, in the past 20 years, have you smoked? Do you have a brain tumor? Or did you ever? So again, it's quick and inexpensive because you're just asking these people right now. You don't need a ton. But we're relying on memory. So some people might forget. They don't remember how long they smoked. They don't remember whatever you're asking them. Like, I don't remember how much I weighed from this year to this year. Things like that. People also could lie. If you're talking about something that we know now, people think bad thoughts about it, they might lie. They might not want to tell you 20 years ago what they were doing. So you have to take that into consideration, and that can affect your study. So the most powerful observational study is a cohort. You follow a group of people over a long period of time. Not sure what happened there. Group of people over a long period of time. So, for example, maybe I start with every kindergartner in Monmouth, in RSU 2. Start with every kindergartner this year, and I follow them all the way up through high school. We get a lot of data. We may not be controlling much, but we see everything that happens, and we can cover some of those lurking variables because we're seeing it as we go and we're watching lots of things. So these are definitely powerful. Again, you still can't do causation, but it's the closest you can come doing a study. But some issues are, I don't know what I did. Okay. You need a lot of people. If people move, they're no longer part of the study. If people come in, they can't be part of the study because they weren't there for the beginning. So you need to start with a really big group, so at the end you still have a decent sample size. It also costs a lot of money to follow people around for 20 years. You're asking these people stuff constantly. It costs money. You've got to have your employees. You got to keep people, lots of stuff. And it takes a long time. It can't be short if you're following people for a long time. So while it's very powerful, it's a lot more work. Everything's give and take. And then finally, the census, or a census, is a list of all individuals in a population. With a certain characteristic. So, for example, characteristic. Every 10 years, the U.S. does what they call the census, like capital C. And they send letters to every single house, and they ask questions about how many people live there and income and all kinds of questions. And they use that information for school funding, for how many people they have in the House of Representatives, stuff like that. So it's a good study because it's asking so many people. It's a huge number of people. Awesome. it gets the most people out of all of these. I don't know why I switched colors, but here you go. The other problem is it's costly to send that many letters or whatever. You need workers to follow up. So if I emailed it to 100 houses and only 3 responded, I got to send someone to the other 97 to try to get those answers. Because if I don't get it from everybody, it's not really a census. And you're still going to leave some people out. If you go to every single door in America and get the answers, you're still going to leave people out because some people don't live in a house. Some people live in a car. Some people are homeless. So those people are going to get left out. So there's no way to actually get everybody. So you do want to be careful the census is going to be the most representative, but it's still not everybody. And if you're talking about people that need money, for example, and you're not asking people that don't have homes, you're leaving out a pretty good chunk of people that might need money. So those are different ways to get studies. We'll learn more about them as we go, but that section 1, 2, let me know if you have any questions.